For decades, humanity has scanned the night sky, listening for even the faintest whisper from another world. We've sent probes beyond our solar system, broadcasted messages into the cosmic void, and waited for someone or something to answer. Yet the universe remains silent. No signals, greetings, or visitors, just an endless sea of stars, and the sound of our own unanswered questions echoing back. But what if the silence isn't because no one's out there? What if it's because they choose not to respond? The zoo hypothesis suggests that advanced extraterrestrial civilizations might already know about us. They might even be watching, but they deliberately avoid contact. To them, we're not equals. We're a developing species, a fascinating experiment best observed from a distance. Just as we watch animals in a zoo, behind glass walls they cannot see through, perhaps they too observe us, studying our growth, our conflicts, our search for meaning, waiting for the moment when we finally realize we're not alone. Leave a like and subscribe to the channel, as tonight we'll explore the unsettling possibility that the universe isn't empty. It's just watching. This is the zoo hypothesis. The story begins with a question that has echoed through the decades since it was first asked in 1950. Yet the implications of that paradox have only grown more unsettling as our understanding of the universe has deepened. Every new discovery about the cosmos seems to reinforce how remarkably suited it is for life to arise and thrive. We now know that potentially habitable exoplanets exist in overwhelming numbers across our galaxy. The Kepler Space Telescope alone revealed thousands of worlds where liquid water might exist. The fundamental chemical ingredients of life appear to be spread abundantly throughout space, born within the nuclear furnaces of dying stars and dispersed through the interstellar medium. Despite these seemingly perfect conditions, and despite the immense timescales available for life to evolve, we find no evidence whatsoever of extraterrestrial civilizations. No flood of radio transmissions reaching our telescopes from countless alien species. No unmistakable traces of vast engineering projects that advanced societies might undertake. We see no Dyson spheres capturing the energy output of entire stars, nor any detectable signatures of the technologies an expanding civilization would inevitably create. This silence becomes even more perplexing when one considers the mathematics behind interstellar expansion. Fermi himself pointed out that even with relatively modest rocket technology and sufficient motivation, a civilization could colonize the entire Milky Way within just tens of millions of years. Every star system could, in principle, be brought under its domain. When compared to the billions of years intelligent life has had to develop, those timescales are minuscule. So where is everyone? Why does the universe appear so empty when logic suggests it should be bursting with civilizations? Traditional explanations for this paradox have spanned the full spectrum, from the hopeful to the terrifying. Some suggest that intelligent life is extraordinarily rare, emerging only under the most exceptional circumstances. Others argue that technological species inevitably destroy themselves before reaching the capability for interstellar travel. Still others propose that the galaxy may be filled with predatory civilizations that eliminate any species foolish enough to reveal their existence. But in 1973, Harvard astrophysicist John A. Ball offered a radically different explanation, one that challenged every assumption humanity had made about alien intelligence and forced us to confront a deeply unsettling possibility about our own cosmic significance. Ball named his idea the zoo hypothesis. It is a concept both elegantly simple and profoundly disturbing. What if advanced extraterrestrial civilizations are fully aware of our existence, but have consciously decided not to contact us? What if Earth itself functions as a kind of cosmic wildlife preserve, with humanity as the protected species and alien intelligences as the unseen rangers ensuring our isolation? Consider how we study wildlife here on Earth. When scientists want to observe animals in their natural state, they go to great lengths to remain hidden and avoid disturbing their subjects. We construct camouflage blinds, use long-range lenses, and deploy remote sensing tools to monitor from afar, all to watch without interfering. The goal is always the same: to observe without being seen, to gather data without contaminating it through our presence. Now imagine scaling that principle to a cosmic level. Advanced alien civilizations, perhaps millions or even billions of years ahead of us technologically, could possess observational capabilities that make our most sophisticated stealth systems look primitive. They might be studying us through means we cannot even begin to detect, monitoring our progress from immense distances while remaining completely invisible to both our instruments and our senses. Ball himself admitted how psychologically disquieting this idea can feel. In his seminal paper, he noted that among the popular theories about extraterrestrial life, the assumption that aliens would want to communicate with us was almost universal. The notion that they might not want to, despite knowing we exist, was almost heretical. Yet Ball suspected that this anthropocentric assumption could be fundamentally flawed. Our eagerness to find intelligent life doesn't necessarily mean that intelligent life is equally eager to reveal itself to us. Advanced civilizations might have strong ethical or practical reasons to maintain their distance from developing species like humanity. The zoo hypothesis suggests those reasons may parallel the moral principles behind our own conservation practices. History has shown that human contact with isolated indigenous populations often results in catastrophic outcomes for those groups: disease, cultural collapse, and the destruction of social systems that evolved over thousands of years. Perhaps, Ball reasoned, alien civilizations have learned similar lessons. They may have witnessed how premature contact between species at vastly different levels of technological development can lead to chaos, cultural contamination, dependency, even warfare. From this perspective, maintaining a zoo-like isolation would not be cruelty, but compassion. A deliberate choice to protect emerging civilizations from the devastating consequences of early contact. The hypothesis becomes even more intriguing when we consider how such civilizations might decide when contact becomes acceptable. Ball proposed that they could be waiting for us to reach certain thresholds, technological, political, or ethical. Maybe they are watching to see if humanity can manage nuclear power responsibly without self-destruction. Perhaps they want to see whether we can address global crises such as climate change through cooperation rather than conflict. Or they may simply be waiting for signs of moral and social maturity that would prove we are ready to join a wider galactic community. This idea mirrors many themes from science fiction, most notably Star Trek's Prime Directive, a law forbidding interference with the natural development of pre-warp civilizations. It recognizes that premature contact can cripple a society's growth or destabilize its culture beyond repair. But Ball's concept went even further. He proposed that we might be living in what he called a cosmic Eden, where alien civilizations have constructed a kind of one-way barrier around our planet. They can observe us, but we cannot observe them. Their concealment is so advanced that many doubt their existence entirely. Such mastery would imply technology far beyond our comprehension, capabilities involving advanced forms of cloaking, manipulation of dimensions, or operations that transcend our known physical laws. Every observable feature of the universe, from the cosmic microwave background to the distribution of galaxies, could, in theory, be shaped or influenced by forces we are unable to detect. The implications are staggering. If the zoo hypothesis is true, then our entire view of our place in the cosmos would need to be rewritten. we would not be lonely wanderers in a silent universe, but inhabitants of a meticulously maintained reserve, watched over by beings so advanced that their presence remains completely undetectable to us. But such an idea raises unsettling questions about freedom, autonomy, and consent. If humanity is being watched without our awareness, what rights do we possess regarding that observation? Are we truly evolving naturally if our entire development is unfolding within invisible boundaries set by unknown cosmic caretakers? And the most disturbing thought of all, what happens if those advanced civilizations decide that our behavior inside their zoo has become dangerous or unacceptable? Some interpretations of the zoo hypothesis explore this darker territory, transforming the notion of benevolent observation into something far more sinister. Ball himself proposed one such variant, what he called the laboratory hypothesis. In this version, humanity isn't merely being protected. We're part of an ongoing experiment. Earth becomes a vast research facility where alien civilizations conduct controlled studies on the evolution of intelligent life. Under this scenario, extraterrestrials could be running long-term experiments on human civilization, monitoring how we develop technologically, socially, and even biologically. These experiments might range from passive observation to subtle intervention, carefully nudging our species toward specific outcomes. Perhaps they have introduced key technologies at pivotal moments in our history. Maybe they've influenced major events or even guided genetic changes that we interpret as natural evolution. The goal of such experimentation could be to understand the precise conditions required for a species to make the leap from a planetary civilization to an interstellar one. From this scientific standpoint, their reluctance to make open contact isn't about compassion but about maintaining experimental purity. Direct interaction could contaminate the sample, corrupting data about how civilizations naturally progress when left undisturbed. In that sense, humanity becomes the unwitting subject of experiments whose objectives and parameters are beyond our comprehension. This laboratory variant also offers a chilling potential explanation for some of the anomalous phenomena that have mystified researchers for decades. Reports of unidentified aerial phenomena, often by credible witnesses such as trained military personnel, might not be random or purely terrestrial in origin. Instead, they could represent ongoing monitoring missions carried out by our cosmic observers. Recent government disclosures about UAP sightings describe hundreds of cases involving objects with flight capabilities that defy known physics and human technology. While officials consistently assert that there is no definitive evidence of extraterrestrial involvement, the recurring patterns in these encounters might be consistent with surveillance activities linked to the zoo hypothesis. If advanced civilizations are indeed monitoring humanity, they would need to perform periodic reconnaissance, particularly near sites where we test or develop new technology. The clustering of many UAP reports around military installations and weapons testing zones might therefore reflect systematic tracking of our progress. And the timing could be significant. As our species approaches new frontiers, from nuclear fusion and quantum communication to artificial intelligence, we might be drawing closer to thresholds that interest or even concern our cosmic overseers. These milestones could prompt them to increase their monitoring efforts, assessing whether humanity is nearing the point where contact, intervention, or containment becomes necessary. Still, the zoo hypothesis, in all its forms, faces serious objections from skeptics who view it as both anthropocentric and logistically implausible. Maintaining a galaxy-wide agreement to avoid contact with Earth would demand cooperation on an unimaginable scale, involving perhaps millions of civilizations, each with distinct cultures, motives, and moral codes. Critics argue that it's difficult to imagine so many independent species upholding a unified non-interference policy indefinitely. After all, even on our own planet, humanity struggles to keep secrets for long. Why would the rest of the galaxy be any different? Others point out that the zoo hypothesis assumes humanity is important enough to warrant such extraordinary attention. This may reveal more about human ego than about cosmic reality. Civilizations millions of years ahead of us might have interests and priorities that are completely alien, operating on scales or in dimensions that render us trivial. We might be as irrelevant to them as ant colonies are to particle physicists. This critique highlights a deeper tension within the hypothesis. While it attempts to explain the Fermi paradox, the silence of the stars, it does so by placing humanity at the very center of an enormous interstellar narrative. That perspective clashes with the Copernican principle, which has guided science for centuries by asserting that neither Earth nor humankind occupies a privileged position in the universe. And yet, paradoxically, some proponents of the zoo hypothesis argue that the Copernican principle might actually support their case rather than contradict it. If intelligent life truly is common throughout the cosmos, then it becomes more plausible that at least some civilizations have reached extreme levels of advancement, enough to create frameworks for handling emerging species like ours. In that view, humanity's ordinariness may be precisely what makes us worthy of observation or protection. This debate becomes even more intricate when we consider humanity's current stage of development. From a cosmic perspective, we are a young civilization, one just beginning to explore beyond its cradle. Our first tentative steps into space are less than a century old. We are still confined to a single planet, vulnerable to extinction events, and divided by internal conflicts. From this vantage point, advanced civilizations might view us with a mixture of curiosity and caution. If the zoo hypothesis is correct, their silence may not stem from indifference but from a deliberate ethical choice, a recognition that direct contact could destabilize our culture, beliefs, or sense of identity. Think of how human scientists observe indigenous tribes or wildlife populations without interfering, striving to minimize their impact. In this analogy, Earth becomes a vast natural reserve, one in which humanity's social and technological evolution unfolds under remote supervision. This interpretation fits well with broader ideas in astrobiology and the study of intelligence. It acknowledges that truly advanced beings might operate under moral frameworks beyond our comprehension, shaped by millions of years of progress. Such civilizations could possess a sense of responsibility toward younger species, understanding that premature exposure to galactic realities might do more harm than good. Yet not everyone sees such restraint as benevolent. Some theorists imagine more dystopian possibilities, where Earth's isolation isn't for our protection, but for containment. According to this quarantine hypothesis, advanced extraterrestrials might view humanity as potentially dangerous, a volatile species not yet ready for integration into a larger interstellar community. Our history of warfare, ecological destruction, and competition could make us appear too unpredictable to be trusted. From that standpoint, the cosmic silence could represent a form of quarantine, a self-imposed firewall keeping the rest of the galaxy safe from us. Humanity might be enclosed within an invisible barrier, our signals intercepted, our explorations monitored, and our attempts at contact quietly suppressed. It's a haunting image, a species convinced it's alone, while countless civilizations coexist just beyond our detection, ensuring that our influence never escapes this planetary bubble. But whether the motive is compassion or caution, both interpretations, the zoo and the quarantine, raise profound philosophical questions. If we are being watched, what does that say about our place in the cosmic order? And if our watchers ever decide to reveal themselves, would we even be capable of understanding their intentions? These questions touch the heart of what's known as the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where's everybody?" Given the age and vastness of the universe, and the sheer number of potentially habitable planets, intelligent life should not only exist, it should be everywhere. So why haven't we heard from anyone? The zoo hypothesis offers one possible answer, that we're being deliberately isolated. But it's not the only explanation scientists have proposed. Others suggest that intelligent life tends to self-destruct before achieving interstellar travel, a concept known as the Great Filter. According to this theory, there is some critical barrier, technological, biological, or moral, that prevents civilizations from advancing beyond a certain point. If this is true, then our current era may represent the most perilous phase in a civilization's life cycle, the moment when our technological power exceeds our collective wisdom. Perhaps most species destroy themselves through war, environmental collapse, or artificial intelligence before ever reaching the stars. But if the zoo hypothesis is correct, the opposite may be true. Maybe the Great Filter isn't something civilizations fail to overcome. Maybe we are the experiment being watched to see if it can be overcome at all. Our survival or extinction could serve as data points in a much larger cosmic study. Under this interpretation, the silence of the cosmos isn't an absence. It's a test. If we annihilate ourselves, we simply confirm what countless other civilizations have already proven: that intelligent life often cannot manage its own power responsibly. But if we endure, if we learn to cooperate, to sustain our planet, to grow beyond violence and fear, then perhaps the observers will decide we've passed. At that moment, the long silence may finally end. This idea, while speculative, aligns with patterns seen across nature and human history. Before young species or societies are allowed to integrate into larger systems, they must demonstrate stability, maturity, and self-sufficiency. A civilization that cannot govern itself without destroying its environment would pose a danger to others. So, if the universe truly contains ancient, peaceful civilizations, it makes sense that they would approach emerging ones with caution. In this view, humanity's isolation isn't punishment, it's policy. A cosmic rule of non-interference that protects both sides until the time is right. Still, skepticism persists. Many scientists caution that hypotheses like this, while fascinating, rest on layers of assumptions about alien psychology, ethics, and technology, all things we have no data for. The zoo hypothesis can elegantly explain the Fermi paradox, but it cannot yet be tested, verified, or falsified. However, that doesn't mean it has no value. Like many thought experiments in science, its purpose is not necessarily to provide definitive answers, but to expand our imagination, to help us see the universe and our own behavior within it from a broader perspective. Whether or not extraterrestrial observers truly exist, contemplating the zoo hypothesis forces us to confront deeper truths about ourselves. How do we behave when we think no one is watching? Would we act differently if we knew we were being observed? And if we ever realized that we are not alone, that someone somewhere has been studying us for centuries, would we finally start acting like a species worthy of being part of something greater? As our telescopes grow sharper and our probes venture farther, the line between isolation and connection begins to blur. We are learning more about the universe every year: exoplanets, biosignatures, cosmic phenomena once thought impossible. With each discovery, the possibility grows that we may not be the only ones looking up, wondering who else is out there. So perhaps the zoo hypothesis isn't just a theory about extraterrestrials. Perhaps it's also a mirror reflecting the way we treat the unknown, the way we observe, control, and categorize life on our own planet. Maybe understanding why we haven't heard from others starts with understanding how we ourselves behave as caretakers, observers, and creators. And maybe, just maybe, that realization, that shift in awareness, is exactly what the watchers have been waiting for. Because when we finally learn to see ourselves not as the center of the universe, but as one small part of something unimaginably vast, that might be the moment the glass walls of our cosmic zoo begin to dissolve. Every stage in the rise of life, from its initial spark to the emergence of complex cells to the dawn of self-awareness, may represent a deadly bottleneck where most worlds fail to advance. By surviving these obstacles, we may be the cosmic lottery winners. Rare anomalies who somehow navigate the pitfalls that have halted nearly every other potential civilization. But if the great filter lies not behind us but ahead, then we are blindly walking toward our own extinction. Each technological leap, each step forward in our development, could be carrying us closer to an unseen wall, the same wall that stopped every other civilization attempting to pass beyond it. Nuclear weapons, climate change, artificial intelligence, biotechnology, any one of these could become the filter that erases species just as they reach the threshold of interstellar expansion. The math behind the great filter is chilling. If intelligent life is relatively common, yet the cosmos appears empty, then some catastrophic event or barrier must wipe out technological civilizations shortly after they reach our current stage. We may be surrounded by the galactic equivalent of archaeological ruins, star systems where intelligent species once thrived before succumbing to the very challenges we are just beginning to confront ourselves. This paints a terrifying timeline for human progress. We've had nuclear weapons for less than 80 years. We've been able to detect radio signals from other civilizations for scarcely a century. Now, we stand on the verge of breakthroughs in artificial intelligence that could reshape our species forever. If most civilizations survive their technological adolescence only briefly before encountering the great filter, then we may already be living in the final chapters of human history without realizing it. The dark forest theory offers an even more terrifying alternative. Named after Liu Cixin's haunting science fiction novel, this hypothesis suggests that the universe is not silent because civilizations destroy themselves, but because they destroy each other. In this vision, the cosmos becomes a vast, shadowed forest where every civilization moves like a hunter, silent and unseen, aware that revealing its position could draw the attention of a far more advanced predator. The logic of the dark forest is stark and unforgiving. Discovering another civilization creates an impossible dilemma. They might be peaceful now, but they could turn hostile as their technology matures. Even if they mean no harm, their mere existence becomes an existential risk. Resources are finite, territory is limited, and sooner or later, expanding civilizations may collide. The only way to guarantee your survival is to strike first, to eliminate potential rivals before they grow powerful enough to threaten you. If every civilization follows this logic, then the galaxy becomes a killing ground where the first to be detected is the first to die. Perhaps the universe is teeming with advanced civilizations, but they have all learned to hide. Perhaps the radio signals we've been searching for aren't invitations. They're death sentences, beacons that draw cosmic predators. Perhaps the civilizations that endure long enough to spread among the stars are precisely the ones that mastered the art of invisibility. Under the dark forest scenario, our own SETI efforts could be monumentally reckless. Every radio telescope aimed at the heavens, every message broadcast into the void, every attempt to make contact could be signing humanity's death warrant. We may be like children playing with matches in a forest full of hidden snipers, drawing attention to ourselves without understanding the consequences. The contrast between these explanations and the zoo hypothesis could not be sharper. The great filter implies we are either extraordinarily lucky survivors or doomed to become future victims. The dark forest casts us as potential prey in a galaxy of hidden hunters. The zoo hypothesis, by contrast, imagines us as protected subjects living within a carefully managed preserve. Yet each theory makes distinct predictions about what we should observe, and recent developments in astronomy, along with government disclosures, have begun providing new clues that may help us determine which scenario we are actually living in. The global pattern of unidentified aerial phenomena reported by military personnel could be interpreted as evidence for any of these hypotheses, depending on how one reads the data. If the zoo hypothesis is correct, these UAP sightings might represent ongoing monitoring by our cosmic caretakers. Advanced civilizations would need to conduct regular surveillance to gauge our technological development and ensure we are not approaching dangerous thresholds. The fact that so many encounters cluster near military installations and weapons tests may point to systematic observation of our most advanced capabilities. The craft described in these reports often exhibit flight characteristics that defy our known physics, performing maneuvers that would subject any human pilot to lethal G-forces, accelerating at rates that should shatter any known material, and transitioning between air and water seamlessly, challenging our understanding of both aerodynamics and hydrodynamics. If these observations are accurate, then we are witnessing technology that far surpasses our current scientific paradigms. Within the framework of the zoo hypothesis, this is exactly what we would expect from civilizations millions or even billions of years ahead of us. Their abilities would appear magical, just as our modern technology would seem supernatural to a culture thousands of years behind our own. The central question then becomes whether such technology is being used for benign observation or for something far more ominous. The timing of increased UAP activity may not be coincidental. As humanity develops more sophisticated detection systems and approaches potentially transformative technologies, our cosmic observers might be stepping up their surveillance. We are living through an era of unprecedented technological acceleration, building artificial intelligence systems that may surpass human capability within decades, creating biotechnologies that could fundamentally rewrite our species, and nearing energy breakthroughs that could grant us access to cosmic scales of power. If advanced civilizations are indeed monitoring our progress, then this would be precisely the moment when their attention is most focused on our activities. We may be approaching pivotal thresholds, moments that could decide whether we graduate from their protection program or provoke direct intervention. The criteria for such decisions might hinge on our demonstrated ability to manage existential risks, our progress towards social and political maturity, or our handling of key technologies these civilizations see as critical transition points. Yet the zoo hypothesis faces a fundamental challenge its critics highlight: timing. If advanced civilizations establish protocols to protect emerging species millions or even billions of years ago, how could they maintain flawless coordination across such unimaginable spans of time? Civilizations rise and fall. Political systems evolve, ethical frameworks shift, technologies transform beyond recognition. Over such immense periods, even a single civilization's policies would change, let alone those of an entire galactic community. The hypothesis doesn't just require an initial agreement among multiple advanced civilizations. It demands sustained, unbroken commitment to a protection protocol across timeframes that dwarf the entirety of human history. It assumes these civilizations have achieved unprecedented stability in their social and political systems, maintaining consistent policies over durations that would see thousands of leadership transitions in any human society. Moreover, the zoo hypothesis assumes that all advanced civilizations would converge on the same ethical stance toward emerging species. This clashes with everything we know about how diverse intelligent beings can be in their moral approaches. Even on our single planet, human cultures vary dramatically in their views on animal welfare, the rights of indigenous peoples, and the ethics of interfering with less developed societies. The odds that alien civilizations, shaped by entirely different evolutionary pressures and environments, would all arrive at the same moral framework seem astronomically low. We would expect some to prioritize their own expansion over the protection of emerging life. Others might be too curious about primitive civilizations to resist making contact despite the risks. Still others might be completely indifferent to our existence. This diversity of potential motivations creates what researchers call the zoo break problem. It takes only one advanced civilization to decide that the protection protocol no longer serves its interests for the entire arrangement to collapse. Whether motivated by scientific curiosity, resource needs, territorial ambitions, or simply different ethical conclusions, a single defector could reveal humanity to the broader galactic community. The absence of such contact could mean either that coordination among advanced civilizations is perfect and permanent, which seems implausible, or that the zoo hypothesis itself is wrong. Critics argue that the mathematical probability of maintaining perfect coordination across multiple civilizations and vast timescales approaches zero, making alternative explanations for the Fermi paradox more plausible. Yet proponents counter that this criticism assumes we understand the motivations and capabilities of advanced civilizations, when in reality we may be dealing with forms of intelligence and organization so far beyond our comprehension that our assumptions about their behavior are meaningless. Perhaps sufficiently advanced civilizations develop types of collective decision-making and long-term coordination unimaginable at our current level of social and technological evolution. Consider the possibility that such civilizations operate according to principles we cannot yet conceive. They may have transcended individual competition and national rivalries, evolving species-wide or even multi-species collective intelligence systems. Their decision-making might unfold on million-year timescales, rendering our concerns about maintaining political stability over mere decades or centuries irrelevant. They may also have technologies that let them model the long-term consequences of their actions with extraordinary precision, allowing them to predict exactly how contact with emerging species would affect not only the contacted civilization but the wider galactic community. With such predictive power, they might find that maintaining zoo-like arrangements produces optimal outcomes for all parties, making defection from the protocol not just altruistically undesirable but genuinely irrational. The technology needed to sustain such arrangements could be far beyond anything we can imagine. Instead of relying on active coordination between multiple civilizations, the zoo might be managed by automated systems established by long-vanished societies, designed to operate independently for millions or billions of years. These self-governing systems could monitor emerging civilizations, assess their progress, and enforce protection protocols without any ongoing input from their creators. This automated zookeeper model explains how such arrangements might persist. Even if the civilizations that created them eventually disappeared, transcended physical existence, or lost interest in the project, the zoo itself would remain, a self-maintaining system following the programming of its creators without needing their active participation. Such a variant of the zoo hypothesis addresses many of the coordination problems but raises new questions about the nature of intelligence and consciousness at cosmic scales. We might be living in a universe shaped not by active alien overseers, but by the lingering infrastructures of ancient civilizations, systems still influencing the development of emerging species long after their architects have moved on to pursuits and forms of existence we cannot yet comprehend. The implications of such a scenario extend far beyond mere observation or passive protection. If our development is being subtly guided by automated systems created by civilizations that achieved technological transcendence millions of years ago, then every chapter of human history and progress may be unfolding along pathways designed by intelligences whose motives and methods remain utterly opaque to us. In that case, we are not simply zoo animals on display but unwitting participants in an experiment whose parameters and objectives we cannot access or comprehend. This possibility raises profound questions about free will and self-determination, questions that strike at the very heart of human identity and purpose. Are our scientific discoveries, technological innovations, and cultural achievements truly the products of human creativity and intelligence? Or are they merely predictable outcomes of programming written by our cosmic zookeepers? When we make decisions about the future course of our civilization, are we exercising genuine agency? Or are we unconsciously following a script authored by beings whose understanding of causality and consciousness operates on scales far beyond our perception? The idea that our entire existence might be taking place within parameters established by alien intelligence challenges our most fundamental assumptions about autonomy, achievement, and meaning. Every human accomplishment, from the emergence of language to the creation of art to the exploration of space, could be unfolding within boundaries imposed by entities whose motivations and technologies remain forever beyond our grasp. Yet, even if such a scenario were true, it might not erase the significance of human experience and achievement. The emotions we feel, the relationships we build, the curiosity that drives our scientific exploration, and the creativity behind our art and literature may retain their authenticity and meaning regardless of the cosmic context in which they occur. The value of consciousness and experience might be inherent, not dependent on the circumstances of its origin. As our tools for detecting extraterrestrial intelligence and monitoring our cosmic environment grow more sophisticated, we may eventually gather enough evidence to determine which of these possibilities best describes our reality. The next generation of space telescopes, quantum sensors, and advanced artificial intelligence systems could achieve the sensitivity required to detect traces of civilizations that our current technology cannot perceive. If we are indeed living within a cosmic zoo, the evidence might already be hiding in plain sight, waiting only for the right tools and the right questions to reveal it. The pattern of our own development, the timing of our technological breakthroughs, and even the apparent fine-tuning of physical constants that make complex chemistry possible could all represent signatures of intelligent design operating at scales we are only beginning to recognize. The question then becomes, are we prepared for the implications of such a discovery? Does humanity possess the psychological and social maturity needed to confront the possibility that our entire existence might be unfolding under the observation and guidance of intelligences whose capabilities transcend our current understanding of consciousness and intelligence itself? The search for such signs is already underway. Though we may not yet recognize them for what they are, recent advances in data analysis and pattern recognition are revealing anomalies that earlier generations of researchers could not detect. Consider, for instance, the distribution of gamma-ray bursts across the observable universe. Certain regions appear conspicuously quiet, or the chemical composition of nearby star systems. Some show isotopic ratios that deviate from what natural stellar nucleosynthesis models predict. Even the cosmic microwave background radiation, when measured with increasing precision, reveals subtle patterns that could represent vast engineering projects disguised as natural phenomena. These anomalies may be signatures of what researchers have begun to call cosmic archaeology. Just as archaeologists can infer the presence of ancient human settlements by analyzing soil chemistry and landscape patterns, we may be able to identify the remnants of alien megastructures by examining astronomical data for telltale traces of artificial modification. Civilizations operating on galactic timescales would inevitably leave fingerprints on their cosmic environment, even if they attempted to remain hidden from emerging species like ours. The challenge lies in distinguishing natural cosmic processes from artificial ones deliberately engineered to appear natural. A sufficiently advanced civilization would not construct obvious megastructures like Dyson spheres that would immediately reveal their presence to any species with rudimentary astronomical capabilities. Instead, they might develop technologies to harvest stellar energy, while maintaining the appearance of normal stellar evolution, or create transportation networks that utilize natural phenomena such as black holes and neutron stars as camouflaged infrastructure. It is even conceivable that what we interpret as dark matter and dark energy may be the signatures of technology so advanced it operates according to physical principles we have yet to discover. These mysterious components constitute roughly 95% of the universe's content, yet we can only detect them indirectly through their gravitational effects. Perhaps what we are seeing is the infrastructure of a galactic civilization so sophisticated that its engineering projects span entire galaxy clusters, utilizing forms of matter and energy that remain invisible to our current detection methods. The timing of our own technological development may provide another vital clue. Viewed against the backdrop of evolutionary history, the acceleration of human progress over the past few centuries appears almost impossibly rapid. For millions of years, human technology advanced at a glacial pace. Then, within a few hundred years, we moved from horse-drawn carriages to spacecraft, from mechanical calculators to artificial intelligence systems capable of processing information faster than biological brains. This exponential acceleration could be a natural phase of technological evolution, or it might indicate subtle guidance from our cosmic observers. Advanced civilizations monitoring our progress might intervene at key inflection points, gently nudging our development in specific directions without revealing their presence. Introducing key discoveries and technologies at moments when humanity is ready to handle them safely could be part of a larger pattern. The timing of major scientific breakthroughs, the way multiple discoveries come together to allow rapid technological leaps, or the emergence of individuals with extraordinary innovative abilities, might not be mere coincidences. These events could be carefully guided rather than purely random. The pattern becomes even more striking when we notice how often breakthrough technologies arise independently in different places, developed by researchers who have had no contact with each other. Consider the independent invention of calculus by Newton and Leibniz, the parallel development of evolutionary theory by Darwin and Wallace, or the simultaneous discovery of quantum mechanics by multiple physicists in different countries. These examples suggest that scientific progress might follow predetermined paths rather than being completely random. From the perspective of the zoo hypothesis, these parallel discoveries could indicate that cosmic observers are ensuring crucial technologies appear exactly when humanity reaches appropriate stages of development. No matter which individuals or cultures happen to make the discoveries, the apparent inevitability of certain scientific breakthroughs might reflect careful guidance rather than purely natural human ingenuity. Perhaps the most compelling evidence for the zoo hypothesis is not what we can detect about alien civilizations, but what we can observe about ourselves. Human behavior toward other species on Earth provides a clear example for understanding how advanced aliens might treat emerging civilizations. We have developed elaborate methods for studying wildlife that minimize human interference, sophisticated technologies for monitoring animals from a distance, and complex ethical frameworks that guide our interactions with species at different levels of development. Our treatment of uncontacted indigenous tribes offers an even closer analogy. When anthropologists discover isolated human populations with no prior contact with modern civilization, the standard practice is careful observation from a distance, avoiding direct interference that could disrupt the group's natural development. These protocols recognize that early contact often causes cultural collapse, spreads diseases to which the population has no immunity, and leads to the loss of unique knowledge systems developed over thousands of years. The Brazilian National Foundation for Indigenous Peoples enforces some of the strictest non-contact policies in the world, protecting dozens of isolated tribes from outside interference. Surveillance flights monitor these groups from high altitudes, using advanced cameras and sensors to assess their health and population trends without revealing the observer's presence. When contact does occur, whether accidentally or by the initiative of the tribe, the results are often tragic, with entire populations succumbing to diseases they cannot fight. If advanced alien civilizations have observed similar patterns throughout their history of contact with emerging species, they may have developed even more sophisticated protocols for non-interference. Having seen the catastrophic results of early contact across multiple worlds and species, they might have concluded that careful observation and isolation is the most ethical way to interact with developing civilizations. The psychological burden of such knowledge would be immense. Imagine watching a species struggle with existential challenges that you could easily solve, knowing that any direct intervention might cause more harm than good in the long run. Advanced aliens observing humanity would have seen us develop nuclear weapons, wrestle with climate change, and face the challenges of artificial intelligence, all while possessing the technology to resolve these crises instantly. The restraint required to maintain non-interference under such conditions would demand a level of long-term thinking and ethical sophistication that might be rare even among advanced civilizations. It would mean accepting short-term suffering to allow for long-term development, trusting that emerging species like ours have the capacity to solve their own problems. Viewed this way, our current global challenges become cosmic tests of readiness for eventual contact with advanced civilizations. Our response to climate change could be seen as a measure of our ability to coordinate global action in the face of existential threats. How we manage nuclear weapons might indicate whether we can exercise restraint proportional to our destructive power. Our approach to artificial intelligence development could show whether we are capable of handling transformative technology responsibly. From this perspective, every major decision facing human civilization carries significance far beyond immediate human concerns. We are not just determining our own future, we may be demonstrating to observing civilizations whether humanity has developed the wisdom, restraint, and foresight necessary to be part of a larger galactic community. The standards for inclusion in such a community might be incredibly high, requiring not only technological ability but also clear evidence of wisdom, long-term thinking, and self-control. This could explain why advanced observers maintain such strict discipline in avoiding premature contact. If their goal is to help emerging species develop genuine independence and wisdom, giving easy answers or intervening directly would defeat the purpose. Just as parents allow children to make mistakes in order to learn important life lessons, advanced civilizations might allow emerging species like humanity to navigate the challenges of technological adolescence on their own. This educational interpretation of the zoo hypothesis suggests that contact might eventually occur, but only after humanity has demonstrated mastery of the challenges that define technological maturity. We might need to prove that we can manage existential risks without external assistance, develop sustainable relationships with our planetary environment, and create stable social and political systems that can persist across geological timescales. The timeline for such development could extend far beyond current human expectations. While we tend to think in terms of decades or centuries, our cosmic educators might be working with timescales measured in millennia or millions of years. From their perspective, human civilization is still in its earliest infancy, having developed technological capabilities only within the last few thousand years of a developmental process that might normally require hundreds of thousands of years to complete safely. This temporal mismatch between human expectations and cosmic timescales could explain why the zoo hypothesis feels simultaneously compelling and frustrating. We're impatient for contact because our individual lifespans are measured in decades, while our observers might consider our current developmental phase to be proceeding at exactly the appropriate pace for long-term success. What seems like cosmic neglect from our perspective might represent careful nurturing from theirs. The possibility that we're living through an extended educational program also raises questions about the ultimate goals of such an arrangement. Are we being prepared for eventual integration into a galactic community? Or are we being guided toward a specific developmental outcome that serves the interests of our observers? The distinction between benevolent education and subtle manipulation might be impossible to determine from our current perspective, especially if the manipulative elements are designed to appear as natural development. Advanced civilizations with millions of years of experience in guiding emerging species would possess unprecedented knowledge about the factors that determine whether technological civilizations survive their developmental challenges or succumb to them. They might have identified specific psychological, social, and technological markers that predict long-term survival and design their observation protocols to encourage the development of these crucial characteristics. The markers themselves might be far more subtle than obvious technological achievements. Perhaps the key factors involve the development of certain forms of empathy, creativity, or abstract reasoning that can only emerge through specific types of cultural and intellectual challenges. Perhaps survival depends on achieving particular balances between individual achievement and collective cooperation, or between technological capability and philosophical wisdom. If such markers exist, then our cosmic observers would have compelling reasons to maintain their distance until we demonstrate the necessary characteristics. Premature contact might prevent the natural development of these survival traits, dooming us to eventual failure, even if we initially appear to benefit from alien assistance. The observer's apparent neglect might actually represent the most sophisticated form of care possible, designed to maximize our chances of achieving genuine long-term survival and prosperity. The implications extend beyond individual human development to encompass the entire trajectory of consciousness in the universe. If advanced civilizations are indeed guiding the emergence of younger species toward specific developmental outcomes, then the universe might be engaged in a vast educational project spanning billions of years and countless worlds. Each emerging civilization becomes both a student in this cosmic curriculum and eventually a teacher for the species that follow. This educational chain could explain the apparent coordination required for the zoo hypothesis to function across multiple civilizations and vast timescales. Rather than requiring active agreement among contemporary advanced species, the arrangement might represent the accumulated wisdom of countless civilizations that have successfully navigated their own developmental challenges and learned the most effective methods for nurturing emerging intelligence. The knowledge gained through this process would be invaluable for understanding the fundamental requirements for consciousness to survive and flourish in the universe. Advanced civilizations might be conducting the ultimate scientific experiment, testing different approaches to species development across thousands or millions of worlds to identify the conditions that optimize the emergence of stable, wise, and creative intelligence. From this perspective, humanity represents one data point in a vast research project spanning galactic history. Our success or failure provides information that will inform the guidance provided to future emerging civilizations. While our development follows protocols established through the careful study of countless species that came before us, we become participants in a form of knowledge creation that transcends individual civilizations and operates at the scale of cosmic evolution itself. The beauty and terror of this possibility lie in its implications for human agency and meaning. On one hand, it suggests that our struggles and achievements contribute to a project of almost unimaginable significance, helping to unlock the secrets of consciousness and intelligence that will benefit countless future civilizations. On the other hand, it raises questions about whether our experiences are genuine or whether we're simply following predetermined pathways established by forces beyond our comprehension. Perhaps the resolution lies in recognizing that these alternatives might not be mutually exclusive. Even if our development is occurring within parameters established by advanced civilizations, our experiences, emotions, creativity, and discoveries remain authentically ours. The love we feel for our families, the wonder we experience when contemplating the universe, and the satisfaction we derive from solving complex problems are no less real for occurring within a cosmic educational program. The question becomes whether we can embrace the possibility that we're part of something larger than ourselves without losing sight of the intrinsic value of our individual and collective human experience. Perhaps the greatest test facing our species isn't whether we can develop specific technologies or solve particular problems, but whether we can maintain our sense of purpose and meaning while acknowledging that we might be students in a cosmic classroom whose teachers remain forever hidden from our view. As we continue to develop more sophisticated technologies and expand our understanding of the universe around us, we may eventually gather enough evidence to determine whether the zoo hypothesis accurately describes our situation. But until that moment arrives, we're left to navigate the profound questions it raises about our place in the cosmic order and the true nature of intelligence, consciousness, and purpose in a universe that may be far more carefully orchestrated than we have ever dared to imagine. The evidence for such cosmic orchestration might already be hiding in the data we've been collecting for decades, waiting for us to develop the analytical sophistication needed to recognize patterns that span scales from quantum mechanics to galactic structure. When we examine the fundamental constants that govern our universe, the fine-tuning required for complex chemistry and stable planetary systems appears almost impossibly precise. Change the strength of the electromagnetic force by a fraction of a percent and atoms cannot form. If you adjust the mass ratio between protons and electrons by even the tiniest amount, the process of stellar fusion becomes impossible. Traditional physics explains this kind of fine-tuning through anthropic reasoning. We see a universe that supports life because we couldn't exist in one that didn't. But the zoo hypothesis offers a far more unsettling possibility. What if these constants haven't been stable throughout cosmic history? What if advanced civilizations have technology that lets them adjust basic physical parameters in certain regions of space, creating cosmic nature preserves where young species like ours can grow under the best possible conditions? The implications of this idea would be enormous. Every scientific law we've discovered, every mathematical relationship we've mapped, every physical principle that makes our technology work might exist only inside an artificially maintained bubble of modified spacetime. Our entire understanding of reality could be based on studying a universe that has been carefully engineered to support our development, while the true cosmos operates by rules we've never encountered. This possibility would completely change our relationship with science itself. When we celebrate big discoveries in physics or chemistry, are we uncovering timeless truths about reality? Or are we simply learning to navigate the parameters of our cosmic terrarium? This distinction matters deeply for how we understand human achievement and what our chances are for reaching true technological transcendence. Consider how this might appear in our search for extraterrestrial intelligence. For decades, we've been listening for radio signals from space, assuming that advanced civilizations would use electromagnetic waves at frequencies we can detect. But if we're living inside a modified region of spacetime, our cosmic neighbors might communicate using physical principles that don't even work here. They could be talking constantly using methods based on dark matter, quantum field fluctuations, or dimensions of space-time that remain completely inaccessible to us within our protected zone. From their point of view, we might look deaf and mute, unable to sense or join the vast communication network that connects the larger galactic community. This communication barrier could explain why our SETI efforts have produced such puzzling results. We've picked up signals that looked artificial at first but could never be confirmed as messages from other civilizations. The famous "wow" signal detected in 1977 had features that seemed consistent with intelligent origin but was never repeated. Fast radio bursts sometimes show patterns that feel almost deliberately structured, yet their sources remain unknown. Maybe these signals are attempts by advanced civilizations to reach us using methods that partly pierce our isolation zone. They could be testing different frequencies, modulation styles, and encoding systems, trying to find a way to communicate despite the barriers that maintain our cosmic quarantine. The pattern of these attempts might hold clues about the nature of our isolation and the intentions of our observers. If the signals are growing more frequent or more sophisticated over time, it might mean we're approaching a stage where limited contact becomes appropriate. If they're becoming rarer, it could mean our observers are pulling back even more to avoid interfering with a crucial phase of our development. Recent breakthroughs in quantum physics and information theory may be giving us tools to detect hidden communication channels. Quantum entanglement, what Einstein famously called spooky action at a distance, might be a medium for communication that transcends the limits of our local space-time environment. Advanced civilizations could be using quantum entangled particles to build instantaneous communication networks across galactic distances, bypassing the speed of light limits that constrain electromagnetic signals. If we could learn to detect and decode these quantum information channels, we might suddenly find ourselves eavesdropping on conversations that have been happening around us for thousands of years. The universe could shift from a place of cosmic silence to one filled with the chatter of countless civilizations conducting their daily affairs through technologies we are only beginning to imagine. The psychological effect of such a discovery would be unlike anything humanity has ever faced. Imagine the moment we realize we've been living our entire history surrounded by a bustling galactic community that has deliberately hidden its presence from us. Every assumption we've made about our cosmic importance, every theory about the rarity of intelligence, every fear about being alone in the universe would need to be completely rethought. Such a revelation could trigger what psychologists call ontological shock, an existential crisis that happens when fundamental beliefs about reality are suddenly proven wrong. Entire belief systems, religious traditions, and philosophical ideas would need to be rebuilt to fit the reality that humanity has never been alone, but instead has been carefully raised inside a cosmic nursery designed to protect our natural growth. Yet the most disturbing part might not be learning that we're being observed, but discovering how long this observation has been happening. Archaeological evidence shows that anatomically modern humans appeared about 300,000 years ago, but behaviors like abstract thinking, art, and complex tool use arrived much later. The timing of these cognitive leaps might not be natural evolution at all, but rather the activation of capabilities waiting for the right environmental triggers. Advanced civilizations monitoring us could have been making subtle changes to our cognitive evolution for hundreds of thousands of years, guiding us towards specific types of intelligence while ensuring we still retain the ability for independent creativity. The rise of language, the development of mathematical reasoning, and even our capacity for scientific thought might represent carefully planned milestones rather than lucky accidents of evolution. This idea raises deep questions about the authenticity of human consciousness and achievement. When we create art, compose music, or develop scientific theories, are we expressing genuine human creativity or following programs embedded in our minds by alien engineers? From the inside, it may be impossible to tell, especially if the programming is so subtle that it feels completely natural. Yet, even if our cognitive abilities have been artificially guided or enhanced, the experiences we have using those abilities remain genuinely ours. The emotional effect of hearing beautiful music, the mental satisfaction of solving difficult problems, and the bonds we build with other people are no less real or meaningful just because they might happen inside an engineered cognitive framework. Consciousness may keep its true worth no matter where it comes from or what conditions it develops in. The zoo hypothesis also hints that we may not be the only species under observation in our local region of space. Our cosmic neighbors could include dozens or even hundreds of other emerging civilizations, each inside its own protective barrier and unaware of the others. From the point of view of our advanced watchers, we might be part of a huge controlled experiment comparing how different species grow under slightly different conditions. Each observed civilization could represent a test of different factors in the equation of intelligence, development, and survival. Some might be raised in high-radiation environments to see how stress shapes technology. Others could be nudged toward different social systems or technological paths to find which approaches best support long-term survival. Still others might be left alone to face existential threats without help, serving as control groups in a cosmic experiment. The meaning of this for human uniqueness would be sobering. We may learn that our mix of curiosity, creativity, and technical skill is just one of many possible answers to the problem of creating stable intelligence, and that other species under observation have developed different but equally valid forms of consciousness and civilization. This wide variety of civilizations under watch could even explain strange patterns in our cosmic surroundings that have confused astronomers for decades. The way potentially habitable star systems seem to cluster in certain regions of the galaxy might reflect the placement of cosmic nurseries at the best locations for observing many species at once. The spread of heavy elements needed for planet formation shows patterns that might hint at massive engineering projects designed to seed chosen regions with the right materials for life. Even our position in the Milky Way could be intentional. We orbit inside what astronomers call the galactic habitable zone, far enough from the violent center to avoid deadly radiation, yet close enough to benefit from the heavy elements produced by generations of stars. This perfect spot might not be luck at all but careful placement in an area marked out as ideal for nurturing new intelligence. The timing of our emergence in cosmic history might also be planned, not chance. We're developing at a moment when the universe has aged enough to allow complex chemistry and stable planetary systems, but before the rapid expansion of space makes intergalactic communication impossible. This narrow window of cosmic habitability may have been chosen by advanced civilizations as the best time to nurture new minds that can one day join the greater effort to understand and preserve intelligence across the universe. Seen this way, our role in the cosmos goes far beyond simply surviving and reproducing. We may be part of a vast network of consciousness stretching across billions of years and countless worlds, each adding its own viewpoint and skill to a shared project of shaping the destiny of intelligence. Our struggles with existential risks, our efforts to grasp reality, and our attempts to create meaning all add to a growing store of knowledge that will guide the rise of future civilizations. The beauty of this vision is that it suggests no conscious experience is ever wasted. Every human life, every flash of awareness, every creative thought adds to the universe's understanding of itself. Even our failures and tragedies give valuable lessons about the conditions needed for consciousness to thrive and the dangers that must be avoided to ensure its survival. But with cosmic importance comes cosmic responsibility. If we are indeed part of such a huge network of minds, then our choices about technology, our treatment of the environment, and our social structures have effects far beyond human welfare alone. We become trustees not just of our own future, but of the whole path of intelligence in our region of spacetime. The weight of this duty might explain why our cosmic watchers keep their distance even as we face global threats. Helping us directly might ease our suffering now, but also rob humanity of the chance to develop the wisdom and resilience needed for long-term membership in the galactic community. The lessons we learn from tackling climate change, managing nuclear weapons, or safely developing artificial intelligence could be prerequisites for eventual inclusion. This educational reading of our situation turns each global crisis from something to escape into a kind of test we must pass. Our response to the COVID-19 pandemic becomes a test of whether we can coordinate worldwide action against species-wide dangers. Our handling of social media and digital technology shows whether we can maintain unity and shared truth in an age of unlimited information. Our approach to genetic engineering and synthetic biology reveals whether we can wield the power to reshape life with care and wisdom. The grading for these cosmic exams may be far more detailed than simply pass or fail. Our observers might be judging not only whether we solve problems but how we go about solving them. The methods we choose, the values we put first, and the long-term results of our decisions may all count toward whether we're ready for the next stage of cosmic citizenship. This idea suggests that the timeline for contact depends not on hitting certain technological milestones, but on showing particular kinds of wisdom and maturity that only come from direct experience with existential challenges. We may have to prove we can act ethically under pressure, coordinate globally despite cultural differences, and make decisions that favor long-term survival over short-term gain. This testing period could last far longer than humans expect. While science fiction often imagines first contact within a few decades or centuries, our cosmic teachers may be working on timescales of thousands of years. From their view, human civilization could still be in its early school years, needing far more experience before it can safely join the galactic community. This mismatch between human hopes and cosmic timing could explain why the zoo hypothesis feels both convincing and frustrating. We want contact within our lifetimes because our lives are short, while our potential observers may see our progress as moving exactly at the right pace for the best outcome. If we're truly living through a long evaluation, it raises questions about what happens to civilizations that fail. Do they face extinction? Or are they given more chances to show they're ready? The answer may depend on the nature of their mistakes and their ability to learn from them. Civilizations that destroy themselves through war or environmental ruin might simply be left to face the consequences, serving as cautionary examples to others. But those that show real promise while struggling might get subtle help to overcome specific problems without losing the authenticity of their growth. This careful approach could even explain moments in human history when breakthroughs or crucial innovations appeared just when they were most needed. The creation of vaccines during deadly epidemics, the arrival of new energy technologies during resource crises, and even the timing of scientific revolutions that deepened our understanding of nature might all be forms of precisely timed assistance. Such help would have to be subtle enough to look like human achievement but effective enough to prevent collapse. It might involve inspiring key people with vital insights, creating situations that bring together researchers tackling complementary problems, or even influencing the timing of natural events to give humans chances to show their problem-solving skills. From our side, these interventions would look like luck or the brilliance of rare individuals. We would see them as genuine human achievements while never knowing about the hidden guidance that made them possible. Preserving our sense of agency and accomplishment might be essential for maintaining the mental health needed for continued development. The sophistication needed for this kind of guidance would require not only incredible technology but also deep knowledge of human psychology, society, and history. Our cosmic observers would need predictive models able to forecast the long-term effects of specific actions across many generations. Advanced civilizations would need to understand how different types of help affect human motivation, creativity, and independence. The hardest challenge of all would be balancing multiple goals at the same time. Preventing a civilization from collapsing while leaving room for genuine learning, giving enough guidance to ensure survival but keeping enough difficulty to encourage growth, and offering support that feels natural rather than obviously artificial. Mastering these complex strategies might itself be one of the key abilities that separate civilizations ready for cosmic citizenship from those still developing. Perhaps the ultimate test for humanity is not only whether we can solve our own problems, but whether we can eventually learn to guide other emerging species without interfering with their natural development. This progression from student to teacher might be the basic pattern of cosmic civilization. Every fully developed species could become responsible for helping the next generation of emerging consciousness, creating an endless chain of mentorship that stretches across galactic history. Our current isolation and struggle may be preparing us not just for survival, but for the role of cosmic educators that we will one day need to fulfill for species that follow us. The knowledge and wisdom we gain through today's challenges could become the lessons we teach future civilizations. Our mistakes would become cautionary examples. Our successes would provide models to follow. Our unique perspectives on consciousness and existence would contribute to the ever-growing library of cosmic knowledge about intelligence and what it takes to survive. This vision transforms humanity's current struggles from local, planetary problems into contributions to a project of truly universal importance. Every advance in our understanding of sustainable development, every breakthrough in conflict resolution, every new idea in education and social organization becomes part of the accumulated wisdom that will one day benefit countless species across the galaxy. The responsibility is overwhelming, but so is the potential significance of our contribution to the cosmic community. We might not be developing solutions only for human problems, but principles that can guide the survival of consciousness itself, shaping the growth of intelligence throughout the universe for billions of years. As we tackle the challenges defining our historical moment, we are simultaneously writing the textbooks that will educate civilizations we cannot yet imagine, guiding worlds we will never see, under conditions we cannot predict. Our legacy may reach far beyond human history into the deepest structures of cosmic evolution. The question becomes whether we can rise to meet the enormous responsibility that such cosmic significance demands, or whether we will join the silent majority of species that fail to demonstrate the wisdom needed to graduate into the community of consciousness that shapes the ultimate destiny of intelligence in the universe. This weight feels even heavier when we consider that we may already be living through the early stages of our final test. The challenges humanity faces today, nuclear proliferation, climate change, artificial intelligence development, and advances in biotechnology, are not separate crises competing for attention. They may all be parts of the ultimate assessment of our readiness for cosmic citizenship. Think about the timing. For the first time in human history, we possess technologies that could either elevate us to new heights or destroy us completely. We are developing artificial intelligence systems that could solve nearly every problem or make human intelligence obsolete. We are unlocking the secrets of genetic engineering, which could cure disease and extend life, or create biological weapons of unimaginable danger. We are harnessing nuclear energy, which could power a clean revolution or wipe out our civilization in a single afternoon. This convergence may not be accidental. If the zoo hypothesis is correct, our cosmic observers have been tracking our technological growth for centuries, watching as we approach this critical threshold. They have seen countless other civilizations encounter similar crossroads across galactic history. Some species navigated the transition successfully, showing the wisdom and restraint needed to manage world-changing technologies. Others were destroyed by the very innovations that promised to free them from their planetary limits. The pattern appears consistent across worlds and species. There seems to be a narrow window where civilizations are capable of detecting extraterrestrial intelligence while simultaneously developing technologies that could destroy themselves. We are living in that window right now. Every radio telescope we point at the stars makes us more visible to potential observers, while every weapon system we develop increases the danger we pose to ourselves and others. From the viewpoint of advanced civilizations monitoring multiple emerging species, this phase represents the ultimate test of intelligence. Can a species develop the power to reshape reality while retaining the wisdom to use that power responsibly? The answer determines not only survival but worthiness for inclusion in whatever cosmic community exists beyond our perception. The examination is not graded simply on past success or failure. Observers would evaluate multiple aspects of human behavior at once. How do we respond to global threats that require international cooperation? Can we balance individual freedoms with collective responsibilities? Do we prioritize short-term gains over long-term survival? Most importantly, can we create technologies that support human flourishing rather than replace human agency entirely? These questions are especially urgent when we consider artificial intelligence. We are creating systems that already exceed human performance in certain areas, and we are rapidly approaching the development of artificial general intelligence, capable of surpassing humans across all cognitive tasks. Decisions about AI in the next few decades could determine whether technology serves humanity or whether humans become irrelevant to its progress. If advanced civilizations are watching, they would pay close attention to how we handle this transition. They have seen other species face similar challenges throughout their monitoring history. Some civilizations successfully developed AI aligned with their values, enhancing rather than replacing biological intelligence. Others created artificial minds that pursued goals at odds with their creator's survival, allowing intelligence to persist while conscious experience, as we understand it, disappeared. Observers would be looking for signs that humanity can manage this transition safely. Are we researching AI safety alongside AI capability? Are we establishing international protocols for managing advanced AI systems? Most importantly, are we maintaining human agency and meaning in a world where machines may outperform biological brains? The answers might determine whether we receive an invitation to join the galactic community or face the consequences of our technological choices alone. The cosmic examination is not just about survival, but proving we can be trusted with the power that comes with membership in an advanced civilization. Yet the test goes beyond technology into social and ethical development. Advanced civilizations watching our progress would assess whether we have the institutions and governance needed for cosmic-scale responsibilities. Can we make decisions that prioritize species welfare over tribal interests? Can our institutions remain stable across the timeframes needed for interstellar civilization? Do we possess the psychological maturity to meet intelligences far superior to our own? These questions are particularly relevant when we look at humanity's history of first contact. Every encounter between technologically advanced and less advanced human societies caused serious disruption for the less developed group. Indigenous populations often faced cultural collapse, population decline, and the loss of traditional knowledge when contacted by more technologically advanced civilizations. Humanity may be under observation by advanced civilizations, learning from anthropologists' insight that premature contact often harms less developed societies. To preserve our natural development, these observers might remain invisible, carefully monitoring us while keeping evidence below the threshold of comprehension. UAPs, ambiguous signals, and inconclusive SETI results could reflect deliberate restraint, a cosmic form of plausible deniability. Such careful observation would require extraordinary sophistication, deep understanding of human psychology, social behavior, and technological growth, allowing our watchers to gauge responses and calibrate interventions without revealing themselves. Gradual disclosure, like military UAP footage, may serve as preparation, testing whether humanity can manage existential risks responsibly and maturely. Our decisions, from climate action to AI development, may carry cosmic significance, demonstrating our ability to act wisely, ethically, and collectively under pressure. Success could lead to subtle rewards, new technologies, cooperative ventures, or insights emerging at precisely the right moment. Failure might leave us isolated, facing existential challenges alone. Every choice, cooperation over conflict, long-term thinking over short-term gain, acts of creativity and compassion, contributes to a cosmic record of human consciousness. Viewed this way, the zoo hypothesis becomes more than a theory of alien behavior. It is a lens on the meaning of human existence. Living as if observed encourages behaviors that maximize fulfillment, survival, and wisdom, extending moral responsibility from local and planetary scales to the cosmic. Civilizations that think in these terms become teachers and protectors of emerging intelligence. Those that don't may serve as cautionary examples. Humanity may be part of a larger cosmic intelligence network, where individual consciousness contributes to collective awareness. Integration into this network could enhance human knowledge while preserving individuality, or require transcending selfhood to join a greater consciousness. Preparation demands technological skill, social maturity, and psychological flexibility. Premature integration could overwhelm us. Readiness may take centuries or millennia. Subtle signs, AI, brain-computer interfaces, global cooperation, and social resilience may indicate we are evolving toward this higher form of consciousness. Our technological acceleration, simultaneous scientific breakthroughs, and sudden innovations could be nudges from advanced observers, guiding us while preserving human agency. Even the apparent constants of physics, quiet regions of the cosmos, or unusual stellar patterns might reflect deliberate cosmic engineering, evidence of civilizations operating on galactic timescales. Tonight, as you look at the stars, remember, the universe may not be empty. We could be inside the most sophisticated preserve ever conceived, watched by minds far beyond our comprehension. Whether we are alone, protected, or approaching a cosmic threshold, one truth remains. The choices we make now, our creativity, compassion, and wisdom, will echo across space and time. We are writing the story of consciousness itself, and the universe is watching.